Hello Algebra 1 students, this is Mr. Wilsey. In this video I am going to start out some of the problems that are going to be on your next problem set. All of these problems are word problems, so you have to actually write an equation. In other words, you have to translate the words into some sort of mathematical sentence that you can solve so that you can find out what the unknown values are in the problem. Okay, so let's begin by looking at number 1 here. I shouldn't have to tell you this, but you can be taking down notes with me because after all I am doing basically the first half of the problem for you. At least I'm giving you a good start on each one of them. Alright, in this problem we have two towns, town A and town B. And they have different starting populations and they also have different yearly growth rates. Okay, each year they add a different number of people. And the question that we want to try to solve is, after how many years will the populations be equal? So this part of the question right here, equal, tells us that we're going to have to write an equation in which two things are equal. Okay? The question is, what goes over here on the left side of the equal sign and what goes over here on the right side of the equal sign? So all equations that we're trying to solve also have to have an unknown. So somewhere in here in the equation there's going to be x's, right? Let's let x represent our unknown. What are we trying to find? Alright? So after we have our equal sign written down, let's try to identify our unknown. Well, we want to know how many years will it take for the two populations to be equal. So this tells me that over on the left side, this expression, right? This expression over here needs to represent the population of town A, and this expression on the right needs to represent, the population of town B. Okay? Our unknown, represented by x, needs to represent the number of years that it will take until population of A equals the population of B. Alright, now let's try to fill in these two boxes here. Let's write an expression for the population of town A first. Well, let's see here. We know that town A starts with a population of 3,225. And we know that each year 100 people are added to the population of the town. So how exactly do we write that? Well, remember that we can use this number, 100, and we can also use our unknown, x. I hope that it's pretty intuitive that we would add 100 people per year times the number of years. Okay? So 3,225 plus 100x. Now, I'm going to leave the rest of this to you. Can you write an expression representing the population of town B? Now, after you have this entire equation written, I want you to solve it for x. The number you get, first of all, it should be a simple number. I'm just telling you that. It won't always be a simple number, but in this case, because I want this to be an easy problem for you, it is a simple number. And that number will represent the number of years it takes for the two populations to be equal to each other. Alright? So this is how you begin problem number 1. Let's look at this next problem. Problem number 2. An architect is designing a rectangular greenhouse that looks kind of like this. Along one wall is a 7-foot storage area and 5 sections for different plants. 1, 2, 3, 4, 5. On the opposite wall is a 4-foot storage area and 6 sections for plants. Now we are told that all of the sections have the same length. Okay, so this distance here is equal to this distance here, which is equal to this distance, which is equal to this distance, and so on. Okay, all of these are the same length. And each of the walls, so this whole thing, has the same length as this whole thing. And how do we know that? Well, right here. It's a rectangle. Okay? The sides are the same length. Now the question they want us to answer is, what is the length of each wall? Okay, so what we're trying to find is this entire length here, which is equal to this entire length here. Now we could let that be our unknown, the length of the entire wall, but it's actually going to be easier for us if we let this length be our unknown, okay, the length of one of the plant sections. So let's let this length represent x. And again, remember, all of these sections have the same length. So if this is x, let's try to write an equation. Now, of course, we know that an equation has an equal sign. On the left-hand side is going to be some expression, and on the right-hand side is going to be some expression. What do you think is going to go in each of these boxes here? Well, we could just phrase it verbally as the entire length of one of the walls. So the entire length of the top might be over on the right, and the entire length of the bottom might be over on the left. Let me write an equation for the length of the entire bottom wall. Let's see. We have 4 feet right off the bat, and we're going to add to that, let's see, how many x's? We have 1x, 2x, 3x, 4x, 5x, 6 x's. So we are adding 6 times x, okay? So 4 plus 6x is an expression that represents this entire length down here. Now this is equal to this length up here. Can you write an expression that represents the length of the entire top wall? I'm sure you can. Put it in here, and then, just like in the previous problem, I want you to solve the resulting equation for x. And again, just like in the previous problem, the value you get for x should be relatively easy to compute, just to let you know that if you're on the right track or not. Okay, so this is how you begin the second problem. Actually, as I was looking at this problem, it's actually very easy to figure out what x is just by looking at the diagram. I'm wondering if you can do that as well. Just look at the diagram and figure out what x is. Anyway, let's move on to the third problem that I want to look at. So one health club charges a $50 sign-up fee and $65 per month. Another club charges a $90 sign-up fee and $45 per month. For what number of months is the cost of the clubs equal? Okay, just like in the last two problems, we want to write an equation. We're going to have an expression over here and an expression over here. The expression on the left is going to be, let's say, the first health club. So the first one that is mentioned in the problem, first club. And then over here, this is going to be the second club. I should probably be a little bit more specific. This should be the price of the first club after a certain number of months. And of course, our unknown is how many months will it take for this equation to be true. So let's just let the number of months be represented by x. So the price of the first club after x months, where x represents a number. So the price of the first club, let's see, we have a $50 sign-up fee and $65 per month. So the $50 sign-up fee is just a flat amount that is included in the price of the first club. And then each month we add $65. So the way to represent that is $65 per month times the number of months. Okay? So from here, I think that you can finish writing the equation, and then, just like in the previous two problems, solve the resulting equation for x in order to determine how many months it will take for the two clubs to have the same price. All right, one last problem that I want to look at. This table of formulas will be available to you in the problem set, and you're going to be using it to death. Let me just show you how to use it by looking at problem number 5. So we are asked, what is the radius of a circle with circumference 22 meters. Okay, this m here is not a variable, it's not an unknown, it's a unit of measure. It represents meters. Okay, so the first question we need to ask ourselves is, which of these given formulas will help us solve this problem? Well, we're interested in a circle, so let's see, it's either this formula or it's this one right here. Let's see, what are we given? We are given the circumference and we want to know the radius. So which of those two formulas having to deal with the circle has what we want and what we need? Well, it's the top one, of course. Okay, so write that formula down. C, or circumference, equals 2 times the number pi times the radius of the circle. So we have our formula. We know C, we know pi. It's telling us to approximate pi with 3.14, but we want the radius. Now, what I would prefer that you do is solve this equation, this formula, for r. Okay? And the way to do that is to divide both sides by 2 pi, because 2 pi on top, 2 pi on bottom cancels out right here, leaving us with c divided by 2 pi equals r. Okay? Once you do this, all you have to do is plug in the numbers. 22 goes in for c, divided by 2 times 3.14 goes in for pi, and then you can plug this into your calculator to calculate the radius. This is what I would prefer that you do. However, what some students do is they plug in the numbers first at this step, and then they solve the resulting equation. So they would do something like this. They would do 22 equals 2 times 3.14 times the radius. And then they would solve this equation for r using the techniques of solving equations. This method is okay, but again, I would prefer that you solve it using just the letters first. Oh, and one last thing. Right here, if you plug this into your calculator, you have to be super duper careful. If you plug it in directly like that, you're going to have to type it in like this. 22 divided by, in parentheses, 2 times 3.14. Okay? This will give you a different answer than if you left out the parentheses. Because in the top case, you are dividing by this product. In the bottom case, you are just dividing by 2, and then you are multiplying the result by 3.14. That's not what you want. Okay? So always be super careful about how you type this stuff into your calculator. Alright, that's all I wanted to cover in this video. Thankfully, it's a relatively short one by my standards, and I hope that you're ready to begin working on the problem set in class.